problem, it says that the functions f of x and g of x are described below. Compare the rate of change and the intercepts of each. What do you notice about the two functions? So my first one, it gives us a graph. I know the graph is a little hard to see, but the y-intercept is at 0, 3. So this point right here is at 0, 3. The next point that I know for sure is the point 3, 4. So about right there, that point is 3, 4. Now, using what we just said, how to find the rate of change, how do I find the rate of change if I'm given these 2 points? Okay, y2 minus y1, which is?
3 minus 0 over 4 minus 3.
Now, which one's y's?
The 3 and the 4.
The 3 and the 4. So if y2 is what? And y1 is? What's x2? And what's x1? Or, yeah, x1. So 4 minus 3 is 1. 3 minus 0 is 3. So my rate of change of my graph is positive 1/3. What's my y-intercept? My y-intercept is 0, 3. Y-intercept is here. Negative 3 on the y is down here. Yes. Yes. As long as you say that, like, y equals 3. Yeah. But most of the time you'll probably see it like this, but yeah. So that's the rate of change of the y-intercept of the graph. Now I have to find the rate of change and the y-intercept of the table. So someone tell me what to write. Minus what?
I'm kind of lost. Right. That's y1 minus y2. I thought it didn't matter which one you used. It does.
Well, let's see. Let's see. Negative 4 minus a negative 3. What does that give me? What is negative 3 minus 0? Negative divided by negative is a? So that gave us 1/3. If we would have done it as y2 minus y1 over x2 minus x1, it would have been written like this. I would have taken my negative 3, that's my y2, minus my y1, so minus a negative 4, divided by x2, which is 0, minus x1. Are you with me? Jade? You good? So a negative 3 minus a negative 4. That becomes a positive. So I get positive 1 over positive 3. Do we get the same thing? So as long as you make sure that you see how 0 and negative 3 were written on the same line of the table? As long as they add up to being on top and bottom of each other, then you're okay to find rate of change. So what's my y-intercept of my table? 0, negative 3. Are there any questions over any part of this? We okay? Alright. Let's look at the next one. It says that the gym offers 3 membership plans: a pay-as-you-go, a regular deal, and an unlimited deal. What does the y-intercept of each function represent? What's the y-intercept represent? What? Not how much you pay per month, and it's not how many times you work out. The initial cost. The y-intercept represents the initial cost. Pay-as-you-go is the cheapest plan until you reach what number of visits to work out? How do you think we're going to set this up? Nope. The way that we can set this up is I'm going to write the equation for the pay-as-you-go. So if I just pay $6 every time I work out, can we agree that the equation of that would be $6x? Do y'all agree with that? And if I look, $50 per month plus 2 times each workout. That's the regular deal. The unlimited deal says it's a $100 per month for an unlimited use. So if I just worked 1 month of the regular deal, that would be $50 and $2 for each time I work out. Do y'all agree that we could be under $100 per month? Do y'all see that? So I'm going to compare pay-as-you-go to the regular deal, because the regular deal can end up being smaller than the unlimited deal. Do y'all get that? Okay. So I'm going to compare the pay-as-you-go to the regular deal. To see where they equal to each other, I'm going to set both of my equations equal to each other. Now I have to find the equation of the regular deal. Do what? No, you're good. How many times am I paying each time I visit? $2. So I'm going to have 2x. $2 per visit. How much is the initial start? Plus $50. Solve for x. What are you talking about? It says, pay-as-you-go is the cheapest plan until what number of visits is reached. They're asking, Well, it's not even, it's not just, no, it's not being over 100. You have it right here. Round that to the next one, and that's your answer.
Gotta ask you this because that's part of it.
But they're just asking you to, it's not the cheapest. They're not asking you for which one when it goes over all of them, just when it's over one of them. Does that make sense? Do what? You probably guessed, right?
What's 6 times 9 and get 54, and that's over the record.
Nope, that's not right. Yes. Yes. So how many visits will it take for us to pay more with the pay-as-you-go than the regular deal?
12. But think about it, because if you're not going to do a 12 and a half workout.
So
That 12 workout, it would
12 and a half does what if we round?
goes up.
If I plugged in 12, I'd still get pay-as-you-go as being cheaper. We have to look at the context that they're giving to us. They want to know how much will it take to go over. So that's when if the answer would have been 12 and a half. So the answer would have been 13. The reason why we round it up is because that we have context to the problem. We have to make sure that our answer abides by the context that's given to us. Are there any questions? Number 3. How many people have heard of the supply and demand? A couple? Okay. Supply and demand is a graph that a lot of times will look something like this, where this could be your supply line, and this is your demand line. So it's two lines graphed on the same graph. The supply and demand graph is saying that if this is supply and this is demand, the more supply you have, the less likely it's going to be in demand. While the more that is in demand, the less likely you have the supply to do that. For example, a lot of times, like here in the South, when we have snow, they think it's going to snow. What is everyone going to do? Laugh, yes. But every time it's like a threat of snow, does a lot of people not go and to the store to try to buy like bread and water and
I think it's hurricane.
okay, hurricane.
Yeah, because
Sorry. We always at snow we always went to the store and bought like bread and water and stuff. So like a hurricane. Do what? North Georgia. Anyways, so if a hurricane comes, everyone rushes to the store to buy bread and water. So what happens is the demand is really, really high for bread and water, but what happens with the bread and water? The supply is very, very low, so people end up running out. So this is what the supply and demand curve is like. That's just a little context between supply and demand. So this number 3 says that supply is modeled by the linear function 0.3x plus 100, where f of x represents the price per tablet in dollars and x represents the number of tablets. Demand is modeled in the table. So this is our supply line and this is our demand, where g of x represents the price per tablet in dollars and x represents the number of tablets. It says find the rate of change of each function Which of the two lines is the steepest? So how do I find the rate of change of an equation? Okay. So y2 minus y1 over x2 minus x1. Am I given a y and an x in the equation? But can we find a y and an x? We can. For this, if we look at our table, our x values are 100, 300, 500, and 600. If we have a linear equation, okay, I want to back up for a sec. Linear equation. Can we all agree that it has a constant rate of change? Can we all agree with that? Not just one person? Yes. So would it be okay if I use smaller numbers than 100, 300, 500 if it's all a constant rate of change? So I want to use numbers 0 and 1. So if I plug in 1 and 0 for my x values, so I plug in 1 for x, what would I get? Someone other than Kinsey, please. If I plug in 0, what would I get? What's my constant rate of change? Do what? 0.3 divided by 1, which is 0.3. What was that? What was 0.3? It was the rate of change, but also what? The slope. So that's the rate of change of my equation. What was the rate of change of my table? Find the rate of change of the table. Everyone should be trying to find the rate of change of the table. Do you have a question? Stretching? Okay. I have a question. I completely forgot to ask this one a while ago. When you post what'd y'all get? Did everyone get that? Which one is the line? Which line is steeper? I still didn't hear you. Supply. Okay, we have one person that says that the supply line is steeper. When you're looking at the steepness, that is saying, I have a graph, the steepness is asking how steep is the line. Like, if I have these 3 lines graphed, this line right here would be the steepest. So which one has oops, which one has a bigger slope? Without looking, don't worry about the negative in front, because steepness can also look something like this. So which one has the steepest slope? The next part says find the equation for g of x. G of x is our graph. What did we say the slope was? What's the next thing we need when we're writing an equation? The y-intercept. To find the y-intercept, if it's not given to you on the graph, we can take our numbers, which are x values, so 100, 300, 500, 600, and our y values, and find the common rate of change. So going from, to find the y-intercept, what does my x value have to be? 0. To go from 0 to 100, how many numbers did I add between 0 and 100? 100. Can we see that from 500 to 600 we added 100? So how many numbers did I add to get from 250 to 190? I didn't add, actually. I subtracted 60, correct? Can y'all see that? So to get from 500 to 600, I subtracted 60. What do you think we're going to do to get from 100 to 0? Okay. To get from 500 to 600, my x values, I subtracted 60 from 250 to get 190. My question was, how do I get from 100 to 0? What am I going to do with this number? Add. So we're going to add 60. So what is 490 plus 60? So that's my equation. We're going to take a lot of days to practice this. You're not. Okay. The second part of the equation says to find the intersection of the two lines. What do you think we're going to do? Set them equal to each other. So take both of my equations, the one that they gave to us, and the one that we just made, and set them equal to each other. This one was given to us. So where do they intersect at? Did you say the other point? What was it? 250? Did you hear her, Auburn? So when I solve for x in this equation, we should have gotten that x equals 500. Is everyone okay with that step? To find the other point, my y value, I had to plug 500 back into one of the equations. When you plug it back in, you should have gotten 250. This point represents where the supply and the demand intersect, like where they're both the exact same. This is also saying that everyone who wants, I'm trying to think of a good example. If I asked the whole class who wanted a piece of candy, pretty sure y'all would all raise your hands, right? Okay, some people are saying no, they don't want a piece of candy. This point represents where whoever wanted a piece of candy, I had the exact number of pieces of candy to give to people who wanted a piece of candy. Does that make sense? But I explained it. Alright. What do y'all think would happen if the supply exceeds the demand? Yes. There would be extra. Alright, I want y'all to try this one on your own. Number 4. Try this one on your own. Compare the y-intercept and the rate of change for each function. Based on this information, which function would you choose? Function A says that a rental store charges $40 for rent a steam cleaner and $4 for each additional hour. If I write a function or the equation, my equation is going to be y equals 4x plus 40.
Where'd you get 40?
I didn't know like right then. You're good? So my rate of change is 4. It's my slope. Yes.
So, yeah.
Right. If you have an equation.
What do we have an equation?
y2 minus y1 over x2 minus x1.
But why do you... What's up with that? Let's pretend like we don't have an equation. Yeah. What would the y be for x?
Alright, can we tell that 3 is less than 4?
Yeah.
So x1, x2,
You said sure you can use that one. Doesn't that mean you can use this one?
you can use any points on here as long as you label it as the higher number of your x values as being the x2.
So if like 3 and 4 were switched, we'd have to make 3 would still be the x1.
If this was 4 and this was 3, then this would still be x1 and this would still be x2 because 3 comes before 1 and 1 comes before 2.
Would y switch too, or would it still be y1 on top?
Now, if we only switch the x's, but we didn't switch the y, then this would still be y2, y1. So my rate of change for my graph was 7.
How did you get 4?
For this one, your rate of change is always a number in front of x. Yes. In an emergency?
No, I actually really had to talk to the bathroom.
Okay, please hurry.
I can do
please.
Okay, why do you need another rate of change?
Do what?
Why do you need
Because we're given two different options. This one is A,
So what's
this one's B.
Duh.
Yes.
Why did it take you that long to answer?
Just, I'll tell you later. Alright, so my rate of change is 7 on this one, my rate of change is 4 on this one. It says, based on this information, which function would you want to choose? Is that right?
You haven't compared a lot. Function B has a lower line.
It says y-intercept is rate of change.
Function B has a
Yeah.
shows a random number, but it's
Okay, for the function, for function A, my y-intercept is 40. The reason why we get y-intercept from is here. For those of you who keep getting confused on how to find the slope and the y-intercept of a function, of an equation, anytime you see an equation, look there.
We're talking about graph.
I know that, but I'm just saying for an equation. If you are struggling, always look at this chart. M equals slope. M is in front of x. B equals y-intercept. B is being added to the x variable. To find the y-intercept of a table when the y-intercept is not given, you have to figure out how to get back to 0. The easiest way to do that is find how much is being added from one number to the next, which is 7.
Then you just multiply 7 times 3. 3.
Wait, Hannah, yes, but stop.
Why? You're confusing.
You're right, but I don't want to get everyone else confused. I'm not getting on to you. You're absolutely right. Don't worry about the 3. Absolutely do not worry about the 3. To get back to 0, I'm at 3 right now. To get back to 0, I go 3 spots back, correct? Do not worry about the 3.
You just said 3.
You just said to get 3 to get to 0. So what do you go 5 by 3 to get 0?
No, you subtract.
Subtract 7?
Subtract 3.
To get from this number to this one, I added 7.
Oh, I thought it was trying to
To go backwards,
You subtract righteously.
I'm going to subtract 7.
Shut up.
Pause. Put your mouth on pause, please. To get from this number to this number, I added 7. To go backwards, I have to subtract 7. So from 46, I'm going to subtract 7. I get 39.
That's 2.
That's at number 2. I'm going to subtract 7 again. I get 32. That's for number 1. Subtract it again to get to 0. So that is 25. Aubrey.
Oh my gosh, not again.
Why do we have
laugh
to
at waiting?
Okay, I have a real question.
Okay.
So when you have 2 functions, you have to get the rate of change and the y-intercept for both functions. You can't just pick one.
It depends on what they're asking for. You got to read the instructions.
What are they even asking for?
Y-intercept and rate of change.
Which function would you choose? Like what? I don't.
Guys, okay, time out.
I have a question.
Next problem. I'm sorry. Ryan has invested $50,000 in the bank at a 1.5% simple interest. The function to represent his money is in the bank is given as this equation. Jamie has invested $20,000 in the bank at 3% simple interest. The function has been given to you to represent his money. Compare the rate of change in y-intercepts for the first 20 years in the bank. You're comparing the rate of change from the interval 0 to 20. You're going to find two ordered pairs. You're going to find the ordered pair for when 0 is my first x and 20 is my second x. So find the two ordered pairs. To find the two ordered pairs, you're going to plug in 0 for x and 20 for x in both equations. Yes, because we're comparing the rate of change. So I have to have, at the end, I have to have 4 ordered pairs. Okay, so for the rate of, what was y'all's ordered pairs?
Hold up, but my 0 is 50,000. 50,000 and 0 is 20,000. And then 67,342.75. I remember girls doing this tomorrow. I wrote.
That'll be okay. In the end, your numbers might be just a tad bit off, but that'll be okay. As long as you're really, really close, it'll be okay.
Whoa.
What about 20,000? 36,122. Is that right?
Oh, I got that.
Okay.
Yeah, I got that.
All right. The rate of change of Ryan, so rate of change of Ryan was roughly 867.14. Is that what y'all got?
Yep.
Roughly,
Yeah.
rate of change of Jamie was 806.11. Roughly, are we good? To find the rate of change, you're going to take this number, subtract that number. You're going to take 20 and subtract 0. What you're going to do is you're going to take the difference between those two numbers, divide by the difference of those two numbers. That's how you find the rate of change. If both Ryan and Jamie are 50 years old right now when they put their money into the bank, will Jamie's savings ever catch up with Ryan?
Yeah, they could.
If Jamie's rate of change is smaller and his initial start value is smaller, will they ever catch up with each other? No.